Okay, so for our first reaction, we have beryllium sulfide, which is an ionic compound, reacting with bromine, which is a non-metal element. What kind of reaction starts that way? Single replacement. Okay, in a single replacement reaction, we have to decide who's going to switch with bromine. So what part of beryllium sulfide needs to switch with bromine? Sulfide. Right, we have to switch the things that are alike in a single replacement reaction. All right, so that means beryllium's new partner is bromine, and sulfur ends up by itself. Okay? Everyone with me so far? All right. This is an ionic compound. What have I not done with it yet? I have not dropped and swapped. All right, so this is a -1. This is a +2, so we're going to be looking at Be, Br2, and I have to check for special elements. Do I have any? Yes, sulfur is as special as they come, comes as an 8. Okay, 1 mark for Be, Br2, 1 mark for S8. Okay, now we're going to balance the whole reaction. That'll be the 3rd mark. I've got 8 sulfur over here, so I need to go over here and get 8 sulfur. That gives me 8 beryllium, so I need to go here to get 8 beryllium. That gives me 16 bromines, and 8 times 2 is 16. So there's your balancing for 1 mark, 8, 8, 8, 1. Kenway. What if they put what? Yeah. They put it up here? Did they put all the numbers up there? Yeah. Okay, for number 2, I have nitrogen gas reacting with potassium metal. What kind of reaction starts with 2 elements reacting with each other? Synthesis. Okay, what happens in a synthesis reaction? They combine. You remember me telling you that I used this to trick people? Did I trick you? Don't have to admit it. Okay, you don't have to admit it. But I imagine I caught a few of you with that. Okay, just because I wrote the non-metal first doesn't mean you don't write this like an ionic compound. Okay, here's what we got. We got to drop and swap this ionic compound. Come on. Okay, this is a -3, this is a +1, so we got K3N as our ionic compound. They get 2 marks if they have it written this way. They have 1 mark if they wrote it backwards. Okay? I'm being very kind. Normally I would just say, come on. But I'll be nice today. Okay. Now we got to balance the whole reaction. I could start by balancing the potassiums, but I'm just going to be changing the number in a minute because I've got 2 nitrogen over here. So I'm going to balance the nitrogen first and then balance the potassium. Okay, so 2 marks if they wrote K3N the right way, 1 mark for balancing the equation. Okay, for number 3. For number 3, I've got copper 2 sulfate reacting with sodium hydroxide. 2 ionic compounds is a double replacement reaction. So we're going to swap the metals so they have new partners. Okay, so that's the partners. Now what do I have to do with them? Drop and swap. Okay, because this is a +2 and this is a -1, so I'll need brackets on that one. I'm not going to need brackets on this one, okay, but I am going to need a 2 on sulfur because sulfate's a -2. 1 mark for CuOH2, okay, and 1 mark for Na2SO4. Yeah, if this one is first, yeah, that's fine. Yeah, it doesn't matter which order the compounds come in as long as they're written metal, non-metal. I don't care if the sodium came first, okay, or the copper came first, doesn't matter. Then it's wrong. Okay, now we got to balance the whole reaction. I've got 2 OHs over here, so I go back over here to make 2 OHs, which also works for my sodium, and I'm done on that one. Okay, so 1 mark for the balancing is 1, 2, 1, 1. Questions on number 3? Okay. For number 4, I have a carbon-hydrogen containing compound reacting with oxygen gas, so this is a combustion reaction. Here's the easiest 2 marks on the quiz. The products of a combustion reaction are always these 2 things. Alright, now we got a balance. Do I have to apply both rules? Yes, I do. Alright, so I start with a 2 there and balance alphabetically. I've got 8 carbons, I've got 20 hydrogens, and I have 16. Okay, plus 10 is 26. So that's 13. 2, 13, 8, 10. Okay, questions on that one? Alright, number 5. I have manganese 4 chloride all by itself. So what kind of reaction is this? Decomposition. Alright, so that means I'm going to break down into manganese and chlorine. Okay, give them 1 mark for manganese. And chlorine is special, so it comes as a 2. They have Cl2, give them a mark for that. And the balancing works out like so. Okay, give them a mark out of 15, please. Write it at the top, let them see it, and then put it in the box. Okay, couple of quick reminders here. Right, yesterday we did the reactions lab, so that's due on Monday. Hopefully a few of you will come in, scheduled help or lunch today, okay, and have me look over what you have done on that so I can give you some tips and pointers and stuff, because really that's your last chance to do it. It's due Monday morning before scheduled help and lunch, obviously, so if you want help on that, that'll be your chance to get it. If you don't get a chance to get help from me, what should you make sure you do while you're putting that report together? Watch the podcast. I mean, I gave out how many gigantic hints, okay, and tips for you in that, okay, especially yesterday when we looked at how to do the reactions for analysis question number 1, okay, things like that. Make sure you watch those. They're not very long, okay. I mean, the first one I think is 12 minutes, and the other one is probably about the same, okay. So it's not a huge investment of time. It's not like you got to watch it and then do the report. You can just have it playing in the background, and when it gets to something important, pay attention. Okay, everybody with me there? All right, so make use of those resources. Toxin projects due Wednesday. All right, so we got to make sure we're getting that done as well. Okay, but you've had already a week, more than a week to work on it. All right, so hopefully you're getting kind of close to the end on that. Your unit exam, March 16th. Okay, so we'll work on predicting today. Okay, we'll kind of finish, I think, mostly finish up predicting today, maybe spend a little bit of time in our short class tomorrow on it. And then Monday we're going to start the mole equation. That'll be Monday, Tuesday, Wednesday, Thursday. Okay, Friday we'll do our unit exam review. I'll give you a little review package you can take home and work on as part of your studying. And then Monday you'll write the test. Okay, so that's what's coming up for you. And then we'll start bio after that. Okay. All right. Okay, so as a quick review here, okay, you had your flow chart today on the quiz. Will you have the flow chart on Tuesday? You will not. I expect that by Tuesday you know how to do the predicting stuff and that you're not going to need that anymore. All right, so let's quickly review here. What's the first thing I need to do with a prediction question? Right. If I'm given the prediction question like these, I have to identify the reaction type. If it's written out in words, what do I have to do first? Can we? Right. I got to write it out like this first. Okay. I've got to write the formulas out, look for special elements like oxygen, swap and drop ionic compounds. Okay. Do all that stuff for just the reactants. Once I get to this point, then I can say, all right, is it synthesis, double replacement, etc. When I figured out what reaction type it is, I need to make the appropriate products. Either I'm swapping the metals for a double replacement, or I'm separating the elements in a decomp reaction, whatever. Okay. Once I'm to that point, I'm checking for special elements again. I'm swapping and dropping ionic compounds, balancing the reaction. Realistically, guys, there's 4 or 5 steps. Okay, and they're pretty much the same for all of them. Everybody with me there? Okay. I want to have you guys do, let's say do the first 5 here. Okay, I'm going to give you a few minutes, do the first 5, and then we're going to go over those again, kind of step by step. If you're getting this, I know that really seems redundant, but, okay, not everybody gets it right away, so have a little understanding. It's always good to hear it again. Okay, then we'll go through the others and kind of move on from there. All right, let's have a look at a few of these. So our first one here, we've got what kind of a reaction? We've got carbon and hydrogen reacting with oxygen. Combustion reaction, okay, products are always CO2 and water. Okay, do I have to apply both rules? Yes, I do, okay, because it's an even number. All right, 2 times 8 is 16. Okay, 2 times 18 is 36, so 18 times 2 is 36. Okay, 16 times 2 is 32, plus 18 is 50. 25 times 2 is 50. Okay, everybody all right with that? Okay. Number 2, I've got sodium phosphate, which is an ionic compound, reacting with lithium oxide, which is an ionic compound. So this is a double replacement. What do I do with the metals? Switch them, right. Okay, so sodium ends up with oxygen, lithium ends up with phosphate. Now I got to drop and swap. Okay, so oxygen's a -2, sodium's a +1, so we're looking at Na2O. Phosphate's a -3, lithium's a +1, so we're looking at Li3PO4. Okay, I'm seeing the odd even problem here for basically 2 of our compounds. Agreed? Okay, well, I'm going to solve my odd even problem as best I can over here. Okay, by putting a 2 in front of the sodium phosphate. So that's going to balance my sodiums if I put a 3 there to get 6. Okay, it gives me 2 phosphates, so I got to go over here and put a 2 in front of that, which of course doubles my odd number. If I go back over here, okay, and put a 3 there, that makes not only my lithium work, but also my oxygen. Everybody okay with that? Yeah? Okay, for number 3, phosphorus reacts with calcium nitride. So what kind of reaction is this? Single replacement. Okay, so in a single replacement reaction, I have to look at the element that is by itself. It's a non-metal. So in this case, phosphorus has to swap out nitrogen, right? So calcium ends up with phosphorus, okay, and nitrogen ends up by itself. And remember, in single replacement reactions, we have the most stuff to check. We have an ionic compound, which needs to be swapped and dropped. Okay, so this is -3, this is +2, so we're going to have Ca3P2. Okay, and I got to check for special elements. Yes, all right. So now I've got a balance. Right now, the only thing that's not in balance is phosphorus, and thankfully for it, it's going to screw everything else up, okay, when we have to balance it out. There's 4 over here. Now there's 4 over there. That gives us 6 calcium, so we got to go back over here and put a 2 in front of that. And then I got to come back over here and put what in front of nitrogen? A 2, right? Okay, questions so far? Don't be afraid to ask, guys. All right, number 4, we got chlorine reacts with potassium. Okay, 2 elements, so it's a synthesis reaction. Okay, has this got the same problem the one on the quiz had? Yeah, the non-metals listed first here. We know when they go together, they're making an ionic compound where the metal has to go first. Okay, so we've got a -1 and a +1, so this is okay the way it is. Okay, it's already been swapped and dropped effectively. Chlorine's out of balance, so a 2 here will balance the chlorine, and a 2 here will balance the potassium. All right, for number 5, I've got disulfur trioxide, molecular compound alone. What kind of reaction is that? Decomposition. All right, so in a decomposition reaction, what am I going to have over here? 2 elements, sulfur and oxygen. Are they special? Both of them are, yeah. 8 and 2. Okay. Now, I got to balance the sulfur first because it's present in the largest number. Okay, so I need to make 8 of them over here. So what do I need to put? 4. Yeah, and that gives me how many oxygen? 12. Okay, before you start on the last 5 here, a couple of tips. Your unit exam's coming up. Okay, I'm not saying that to stress you out. I'm saying so I can tell you a couple things that might help you. Do I record every quiz we do? Yeah. Okay. When you're studying for your test, go into your Power School, okay, and look at your marks. If there's a quiz you didn't do well on, you should watch the podcast for that day. I put a link to that in the task. So if you click on the quiz in Power School, it'll come up and it'll show a link that says podcast of quiz number 1. Click on that, and what's the first thing we do? The first thing that'll come up when you start playing that podcast is me going over the quiz, right? So you don't even have to look for it. It's always the first thing. Okay, so it would be advisable as a way to study for your test to have a look at the podcast of any quizzes you didn't do well on. Okay, so you can kind of see where you went wrong. It's especially useful if you keep your quizzes. Probably should have told you that a while ago. Yeah, hopefully you have. That's why I give them back to you. Okay, so advisable that that's one of the things that you try, okay, as a way to study for the test. Okay, what are some other things you could do to study for this test? Right, okay, I've given you a whole bunch of worksheets, right? Okay, now most of you have got all of them done, okay, and if you don't, well, you should finish them. That could be a good way to study for your test. If you're done them all, I'm not saying do them all over again. That's ridiculous, okay? But could you pick, let's say, from a naming sheet that has 40 questions on it, 10 of them at random and see if you get them right? Okay, if you pick 10 at random from a worksheet and get them all right, do you need to do that anymore? Nope, okay? That's a good way to know how well you know something and whether you need to spend any more time on it, okay? That's kind of self-evaluation, all right? So that's another good thing you could do. Do you have notes? Okay, is it advisable to read those through? Yeah, you don't want to spend a lot of time in chemistry reading your notes, okay? I'm not saying don't do it. Don't spend lots of time, because some people are like, oh, I got to read my notes, I have them, I got to read them all the time. Not for chemistry. Chemistry is much more skill-based. Can you do this thing? Can you do that thing? Okay, that's where the most marks are in chemistry. So practicing your skills is the more important thing to do while studying. I'm not saying reading your notes isn't important. It is, okay? But spend more time practicing skills like naming, balancing, writing reactions, that kind of stuff. That's worth way more marks on the test than stuff that's like recall. You know, like what's a solute? Okay, I mean, you kind of know that already. That's going to be like 1 multiple choice mark. Okay, whereas there's a lot of skill marks. Okay, everyone follow me there? Just so you know, my tests are always partly multiple choice and part written. All right, and there's always more marks in the written, always. All right, so I think on this one there's 33 or 35 multiple choice questions, and then there's 8 or 9 written questions. Okay, the written questions will be things like, here's a couple of reactions, balance them. Here's a few reactions, predict the products in balance. And then a few things that ask, you know, here's a situation using your knowledge of solubility or using your knowledge of the polar nature of water, answer this question. Okay, and you have to maybe write like a short, you know, paragraph or a couple of sentences or something. Okay, so that's the kind of stuff to think about when you're preparing for your test. Okay? Right. Okay, let's have you do 6 through 10 there. For number 6 here, I've got copper metal element reacting with lithium chloride, which is an ionic compound, so this is a single replacement reaction. Since copper's a metal, it has to switch with lithium. All right, so chlorine's new partner is copper. Lithium is alone. Lithium's not special, so it doesn't need any numbers beside it. But I have one problem. Right, copper carries multiple charges. I don't know which one to use because copper was an element in the reactants and didn't have a charge. So which one do I use? The first one, because it's most common, and for copper that's 2. Okay, so copper 2 plus, okay, chlorine's 1 minus, we're looking at Cu, Cl2, so then we'll have to put a 2 there and a 2 there to make everything work. All right, that's that one little thing that can come up once in a while that we have to remember. All right, for number 7, we've got potassium permanganate, the little purple crystals that make your skin turn brown, okay, reacting with iron sulfide, iron 2 sulfide, okay, because we might need that later. Double replacement reaction, metals have to swap. So potassium's new partner is sulfur. Iron's new partner is permanganate. Okay, now we got to drop and swap. This one's a -2, this one's a +1, so we're looking at K2S. Okay, and iron's a 2+, permanganate's a 1-, so this will need brackets with a 2 outside of them. Okay, and then looks like a 2 right here will pretty much fix all the balancing. Jacob. So you're saying in this situation here, if I put brackets around it, even though it doesn't need them? We're technically not supposed to. I mean, I don't really see anything wrong with it, but technically if it doesn't need them, they're not supposed to get them. Yeah. Sabina. Over here, so I went back to what it was in the reactants. It was with sulfur. Sulfur's a -2, so it had to be a +2 here. Yeah. So if it's in a compound, we can always check. If it's by itself, then we have to go with the most common. Okay, for number 8. Okay, we've got hydrogen gas reacting with nitrogen gas, 2 elements reacting with each other. Which one should I list first, do you suppose? Hydrogen, yeah. I would assume that since it's reacting with nitrogen, which is always a nonmetal, hydrogen's probably going to act as a metal here. Here's the other reason I want to assume that. If I assume that hydrogen is a nonmetal, I have no idea how they're going to go together, because then I can't drop and swap and figure out the numbers. The only way I can figure out the actual numbers is to put them in an ionic compound together. Okay, so I'm going to say it's H with N, and then go, this is a -3, this is a +1, okay, and go H3N. All right, everyone okay with that? All right. Now, what do I have to do for balancing? Yep. Okay, and that'll make it work. Okay, for number 9, I've got C5H12 plus oxygen, so we're looking at combustion reaction. Okay, so our products are CO2 and water. Okay, odd number, so I don't need to apply the rule of 2. 5 here, 6 there. 5 times 2 is 10, plus 6 more is 16. 8 times 2 is 16. And our last one, we have hydrogen phosphide, okay, or phosphoric acid. Okay, we are looking at a decomposition reaction here. So we got hydrogen and phosphorus separately. Hydrogen special? Yep, it's a 2. Phosphorus special? Yep, it's a 4. Okay, so we got to go back over here and balance the phosphorus and put a 6 there to make the hydrogen work. Okay, questions on any of those? All right, finish up the prediction worksheets I gave you on Tuesday. Okay, that is what we need to finish today, is those questions. All right, so that's what you're working on for the rest of class. You may. Okay, if there's any questions on any of those guys, let me know and we can certainly go over them.